Today we're going to study the image formation by mirrors. So if we take some straight mirror like this one, this part here doesn't reflect light, but this on the left side it reflects light. And let's see here is the horizontal axis, and then we have some image like a candle or a pen or something. So I put a bar like this. So we have this bar here. Now this bar, we assuming we have light in the room, so the light is going to hit the bar. So some of the light will reflect. So let's take a beam or a ray of light is going to come out of the object. It's going to reflect out of the object like this. Okay. And then I have to be careful because the image has to be same distance. Let me put here, same distance here, and then let me put here. So it'll be something like this. It's going to reflect. Let me change the paper. It's going to reflect like that. And this is just the projection. You see, I have to do reflect like that. So you have coming in, reflecting, and then the projection. This is the projection of light. This is not light, this is just the projection of this ray here. And let me take another ray coming from the bottom of the ruler. So take another ray coming from the bottom of the ruler. Let me see. I make it go to the same location like here. Maybe let's make it red. So it's gonna go like that. This is coming from the bottom of the ruler. So I have to do this. It's gonna reflect like that. Okay, so let me choose the angles here. So this angle here is equal to that angle. Call it theta. That's theta. Okay. The other angle also, this angle here is equal to that angle. Let me put two lines. You see the angle with two lines is equal to this angle with two lines. And the image will be here. This is the image of that ruler. And this image is not real. Image is virtual. It's not real. It's virtual. So the reason I say that the image is not real is because you can see it's made by the projection of the rays. You see these red rays? There's a projection. And this blue or purple ray, projection. So this is not light. This here is not light. It's just the projection of light on this. So this image on this area here. So the image is virtual. It's not made by light, only by the projection of the rays of light. So this distance here, we call it DO for object. And this distance here, we call it DI. So DO is equal to DI. Same length. Also, we call this H, and this one here, H prime. So H is equal to H prime. This is for a mirror that's flat. Okay. Now let's study the concave mirror. We're going to study now the concave mirror. So I put here concave mirror. Okay. For the concave for the concave mirror, it's like it's a mirror that's caved in. It's like that. So this side here doesn't reflect light. So the light is coming from the left. So we choose the axis, the horizontal axis. Okay. Now, this mirror here, this concave mirror, is coming like it's coming from some sphere. So let me make the sphere like this. See, this is the sphere. Now, this is the radius. Now, if I take, let's see, I take some ray of light is coming in. Well, before I draw the ray of light, let me look at here, this point here, halfway. So this is the focal point. I call it F, focal point, this one. So this focal point for this concave mirror, the focal point is equal to the radius divided by 2. Now, all the light that's coming in, like let's see from far away, let's see this light here coming like that, is going to go through the focal point. If you take another ray, it will go through the focal point. If you take another ray here, it will go through the focal point. Okay, so all rays, they go through that focal point. Okay, so this mirror is convergent. It converges light into one point. This is concave mirror. If we want to look at, and here one thing I want to mention is F is positive. Okay, the focal distance is positive. And the focal distance is this one. From the focal point to that point here, I call it O. So let me use different color. That's the focal distance from here to there. And this is here the focal point. This is for concave mirror. So I need to straighten this up. Now let's study. So this is for concave mirror. So I go like this. Go down. Concave mirror. Now let's study the convex mirror. So convex mirror, I'll show you. This side here doesn't reflect light, the right side. The one that reflects light is the left side. So I draw again the horizontal line. Here is the horizontal line. And let me again look at the circle for this convex mirror. So I put here convex mirror. And this will be the radius R. That's the radius R. Now, what we do is we need to look at the distance halfway between this point here and this. This is the origin. We can call that point C. And here is the distance between, exactly between these 2 points. That's the focal point. We call it F. And this F again, the focal point. I can use small f because that's the focal distance. This is here. That's the focal distance. And this is the focal point. Same thing here. The focal distance is equal to r over 2. Now what I need to do, I need to look at what's going to happen to the rays. So I bring one ray, come in from far away, and it's horizontal like that. This ray will reflect off the surface. So I go something like this. This is just, it's going to reflect like that. That's the reflection. And let me take up this point here. So this angle here is equal to that angle. The angles are equal to each other. Let's call this one alpha, and that's alpha. Okay. Now let's take another ray. So some ray coming this way, horizontal. What's going to happen? It's going to kind of reflect this way, such that the reflected ray is in the line, this line here. So that's the reflected ray, reflected ray. Looks like that. And the angle, let me go this way. So this angle here, theta, is equal to that angle theta. The angles are equal to each other. So if I take another ray, it's coming this way, it's gonna try to go through the focal point, but it can't. So the projection is the one that's gonna go. So I put here projection of the reflected light, like that. Okay, and so all these rays that's coming in, they're gonna reflect in such fashion, like that. So these are just projections. These 1, 2, 3, 4, just projection. We have 4 reflected, 1, 2, 3, 4, 4 incidence rays here. And you can see that the reflected rays, their projection try to go through the focal point. So this is for convex mirror. So this is convex mirror, like that. Okay, now what we're gonna do, we're gonna look at the image if we use a concave mirror. So we're going to use concave mirror like this. This is concave mirror. I put here these lines like that. And we try to find the image of this, of some object. Okay, here is the this x-axis, horizontal one. And then I put some image or some object, I'm sorry. Here is the object. I have some height h. So this is the object. Okay, so we need to again to find the focal point. So I can just go like this. This is the center. I put here O. This is the radius R. The focal point is going to be halfway, so the focal point is there. That's F. This is the focal point. Okay, so let's take a ray coming in from the top of the object. Here is a ray coming parallel like that. It's going to hit the surface and it's going to reflect like that. Like that. So it's gonna go through the focal point and keep going. Now we take another ray. Okay, let's take this ray for example, going this way, go towards the center or toward this point here. I call it C, and it's gonna reflect with the same angle like that, like that. So the image actually is here. You need to join this intersection. That's the image. This is H prime. Okay. Now we can do, you can use more than two rays. I'm just using two. There is another one that can actually go through a focal point, another one, to find this image. But I'm just using, I can use just two, you know. It depends, because you see my drawing is different. If I want to make some ray going in like this through the focal, is gonna come out because of the way I drew, is not gonna hit that point. So I used only two rays. Okay, actually, if I wanted to make a third ray, I have to make the light coming in like this. You see, it's gonna hit the focal point, and then it's gonna bounce parallel. But you see, because the way I drew it, that third ray won't fit because of the picture. So I'm using only two rays, these two red rays, to form the image. So let's see, want to find out the location of the image. So use the formula which we did in the previous video, 1 over d0, and here is the distance. This is d0 or d0. That's from here to actually to the center is this one here. That's d0. Okay, and the image I put here 1 over the image. So the image, I go like this. This is the eye. Is this one here? That's the eye. Is from here to the center. That's the eye. Okay, so I put here the eye is equal to 1 over f. And f is this distance from here to there. That's f. That's distance f there. So if you know f, because usually you know the radius of the mirror. If you know the radius, you're gonna know f. You know where you put the object, so you know the O. You know it because you're the one who put the object there. And the image, you can calculate it from here. You can just do the algebra. You can say 1 over di is equal to 1 over f minus 1 over do, which gives me do minus f over do times f. And from here I can find di. Di is equal to do times f, okay, over do minus f. And here is the di if I want to find that distance. Okay.